Good afternoon, Algebra 1. This is Mr. Cottle coming to you sick from the couch. We're going to look at today section 3.4, solving multi-step inequalities, which is really nothing more than what we've been doing, and it's certainly within our realm of abilities because it's very similar to solving multi-step equations, except we'll have to express our answer on a number line at the end. All right, so here's our instructions. Solve the following using inequalities and then graph their solutions. So if I look at this first problem here, we see this is really just a two-step equation, right? So what would we do? We'd add 12 to both sides, all right, and then we'd proceed on to see what our next step would be. We'd have 3x now less than 15. Now we divide both sides by 3. All right, which would reveal us our answer that x is less than 5. So when I go to put this on our number line, I know we're looking at 5 as the center point. We graph one number to the left and one number to the right to fill in our number line. And then we're also looking for an open circle because there's no line under our inequality here, which means we need an open circle on our number line. Remember, one way to double check these answers is to select the answer that you took, plug it back in, and make sure that it makes sense. Is 4 less than 5? Yes. So that way we can verify that our answer is correct. All right, so really all this page is going to be is taking us through some of the different types of scenarios that can occur. All right, so on this one, our first step would be to add 1 to both sides, leaving us negative 8x greater than or equal to 16. Now with this, we're going to divide both sides by a negative 8, which should throw off an alarm with you to flip the inequality. All right, notice here what has happened from our initial inequality to our final answer. It is flipped because we multiplied or divided by a negative number. All right, then for our inequality, we're looking for the number negative 2 as the center point. Be careful when you are, why isn't this working? Okay, be careful when you are graphing on in the negatives. We have the negative 2 there in the middle, but make sure you're keeping it straight. The negative 3 would be to the left and negative 1 to the right. We would use a filled-in circle because there's a line under our inequality, so it's a solid circle. And we would shade to the left because those are all the numbers that are less than or equal to negative 2. All right, but don't forget the key concept here. The only thing that really makes these difference in equations is if you divide or multiply by a negative number, flip that inequality. All right, let's check out this one. First step would be distributing. All right, once we did that, here's what we got. We'd have 6n plus 2, and then that 2 and the 22 that was originally there on the outside are like terms, so I will combine them. All right, and then now we're just back to solving a two-step equation. I'd subtract by 24 on both sides, and I'd get that negative 12 is greater than or equal to 6n. Now I would divide both sides by 6 to get this as our answer. Notice here that we did not flip the inequality. Sometimes people will ask, why didn't we flip that inequality? There was a negative number right here. Remember that it's the step that we do. We divided by a positive 6. So although this 12 is negative here, that doesn't matter. It's about what we do to keep the inequality balanced. We divided by a positive number, so we would not flip the inequality. And then we'd get our number line graphed, ends on the other side in this case, but don't let that bring you down. Negative 2 is our number of focus. Goes right there in the middle. Make sure you set up your negative number line correctly. We did a filled-in circle, and we would need to shade to the right. Oh, but let's double check here. See if that's correct. Remember, what you can always do here is take a number, plug it in. So on this, if I had negative 2 is greater than or equal to -1, which is the way I currently have shaded, we would say, hey, that isn't a true statement. -2 is not bigger than -1. So that means our initial shaded region is incorrect. Alright, so I can't erase that part, so I'm going to just X it out, and we'll really be shaded this way. But that shows us the value of checking your answer. You always want to go back and make sure that the numbers that you have shaded make sense with your inequality. Alright, so this one we have another step of distributing. We have some like terms to combine with the 6 and 10 as our constants. And then we're just solving two-step equations. So you'll notice that these are no more difficult than two-step equations or multi-step equations, whatever have you. It's just our answers now get graphed onto the number line. So we'd continue on by subtracting 16 from both sides, and then we need to divide both sides by a -5. So that tells us we're going to need to flip that inequality. Alright, anytime you multiply or divide by a negative number, flip that inequality. Alright, so then for our answer here, on our number line, -5 is the center point, filled in circle because there's a line underneath our inequality, and shaded in the direction to make x larger than -5. So all the numbers larger than -5. All right, and there's some other examples here if you wanted to give these a try too. And these can even have variables on both sides. That's fine. We're about to see some of those on the back side. All right, so just like with equations where they could be true, or we can find one solution, sometimes they'd have no solutions or infinite solutions. That's going to be the same thing with inequalities. We just saw some that have kind of the standard answer that you would expect, where we can graph it on a number line. That's the equivalent of having one solution. There's also ones that are always true and never true. Just like there was one with linear equations of infinite solutions and no solutions. Here's what one that's true would look like. And remember, sometimes these will be disguised. All right, after I distribute here, we would get 10 minus 8a. And you may recognize, hey, both sides of this inequality are the same, which meant for linear equations that we had infinite solutions. It's going to be similar with inequalities, but we have to kind of take it further to see the final step. So here I added 8a on both sides, and I got this statement here, which is 10 is greater than or equal to 10. That's a true statement, only because there's a line here under our inequality. So you can't just identify earlier on that they're the same and say infinite solutions, because if this problem would have been slightly different, and we would have got 10 is greater than 10, this would be no solutions because 10 is not greater than 10. But in our case, it will work because 10 is allowed to be equal to 10. So what this tells us is that no matter what we plug in for x, we would get an answer that works. That's infinite solutions. What that would look like on a number line is everything is shaded, and you could put whatever number you wanted there in the middle. I just chose 0 to center out my number line, but everything is shaded in all directions. No matter what you plug in for x, you would get a true statement. Right, and then there's also some that are never true. All right, so on this problem here, we had some variables on the same side. Remember with that, they are treated as like terms. So the 7m and the -m will combine here for a 6m. All right, and now I'm working to continue to solve this inequality by getting my variables onto the same side, which I could do by subtracting 6m from both sides, which will cause both of them to cancel out. Now, this lands us at this final statement of negative 5 is greater than 7, which is never true. That tells us that no matter what we plug into the original scenario, nothing will ever make this inequality work. This is no solution. If you wanted to put this as a number line, it's just a blank number line. There's nowhere I could shade on this to make it work. All right, and that's the equivalent here of having no solutions, the equivalent of having infinite solutions, and then on the last page of just having one solution, which we can now graph on a number line.